Okay, 8.2, day 1, the first day of this section, is all about graphing and asymptotes. So we got rational function, and the whole thing looks something like this. Your function should look something like that. Let's focus this thing. Maybe that's better. A vertical asymptote happens when the bottom equals 0. So in this case, we had x minus h equals 0. I add h over and get x equals h. My horizontal asymptote happens when y equals k, just that number on the outside there. Domain, all reals except x equals h. Range, all reals except y equals k. So it's all real numbers except your horizontal and your vertical asymptote. Okay, so let's look at graphing this thing. So graphing it, my vertical asymptote is when the bottom is equal to 0. That happens right in this case when x equals 0. My horizontal asymptote is the number on the outside. Well, right here we don't have a number on the outside, so it's also 0. My domain and range, I'm going to write them. This double stem r is a little shortcut for all real numbers. And then you say except x cannot be 0, just like the vertical asymptote. Range, all real numbers, except y cannot be 0 because of the horizontal asymptote. So then the next thing to do here is to graph it. And to graph this thing, the first thing I'm going to do is graph my vertical and my horizontal asymptote. So in this case, they happen at 0 and 0. So it's right along the coordinate plane. An asymptote kind of cuts the graph in two parts. So then the next thing I'm going to do is I'm going to put my points in here, and right in the middle, I'm going to put my asymptotes, 0, 0. And I don't graph that as a point, but it helps me choose my x values. So if I go up from here, I get 1 and 2. If I go down, -1 and -2. I don't actually graph that one. It's just there to show me how to pick my x values. Then if I do just a little math in here, if I plug in 1, 3 divided by 1 is 3, -3, and I have 1.5 and -1.5. I just take my x value and plug it into my original function. So now I have these points, 2, 1.5, 1, 1, 2, 3, and that's half my graph. It swings down like this, runs right along the asymptote but doesn't cross it. My other half is on the other side, -1, -3, -2, -1.5, runs right along like that. There's your graphing of a rational function. Let's do another one. So graphing this thing, vertical asymptote is when the bottom is equal to 0. That happens at x equals 1, because 1 minus 1 is 0. Horizontal asymptote is the number on the outside, so in this case, 3. Remember my domain and range, all real numbers, except x cannot be 1. Range, all real numbers, except y cannot be 3. And then I take my vertical and my horizontal and put them right in the middle. And then I'm going to graph those. Vertical is at 1, so at +1 I go straight up and down. Horizontal is at 3, 1, 2, 3, and I go straight across. Now from there, I'm just going to pick x values. So I'm going to go up from here, 2, 3, and down, 0, -1. And so if I plug in like numbers, so I do 3 minus 1, I get 2. 2 divided by 2 is 1, plus 3 gives me 4. Oops, I did the wrong one, didn't I? 3 minus 4, that goes with that one. Ah, you're getting the gist of it. No, that's right. 4, and then we have 5. And when we plug in, we get 1 and 2. So that when I graph this, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, and 2, 5. Remember, it hugs right along the asymptote but doesn't cross it. 0, 1, -1, 2. Runs right along it but doesn't cross it. Let's do one more. Graphing this thing, vertical asymptote happens at -2 this time. Horizontal asymptote happens at -4. Domain, all real numbers, x cannot be -2. Range, all real numbers, y cannot be -4. I put those in my graph, -2, -4, and I graph them, -2, straight up and down, -4, straight across. This helps me pick my x values, so I'm going to go -1, 0, and -3, -4. And when I plug these x values in, which you're just doing in your calculator, by the way, this is the y values you get. So that when I plot these points, 0, -5, -1, -4.5, oh, these are switched. 1, -5, 0, -4.5, so it looks like that. -3, -3, -4, -3.5, and it looks like that. Second part of this is, so far all we've had is like where the x is only on the bottom. Now we're going to do the case where there's an x on top and on bottom. So vertical asymptote still happens when the bottom equals 0. My horizontal asymptote is different. Cross this off and change it to bottom. If my highest degree is on the bottom, then it's just y equals 0. If they're equal, so if you have like ax squared over bx squared, see these powers are equal, I just take the number in front and I get y equals a over b, whatever those numbers in front of them are. So looking at the last few examples on here, my vertical asymptote happens when the bottom is equal to 0, 5x minus 10 equals 0, add 10 over, divide by 5, and I get x equals 2. Horizontal asymptote, my powers are equal here. I have x on top and x on bottom. So I just look at the numbers in front. It's 3 over 5. Y equals 3 over 5. Second one, vertical asymptote is when the bottom equals 0. So if I have x squared plus 5x plus 6 equals 0, to solve this thing, you should think in your head, I need to factor. So what multiplies to be 6 adds to be 5 would be 3 and 2. So this turns into x plus 3, x plus 2 equals 0, which means I have two vertical asymptotes at -2 and -3. Horizontal asymptotes, my highest degree is an x squared. There's no x squared on the top, so it's only on the bottom. What happens when it's on the bottom? It's y equals 0. Last one. We want vertical asymptote at the bottom to be equal to 0. 3x squared minus 27 equals 0. So then I have 3x squared equals 27 because I added that over. If I divide by 3, I get x squared equals 9. And when I take the square root, I get plus or minus 3. Horizontal asymptote, my highest power is an x squared. It's on top and on bottom. They're equal. So that means I just look at the numbers in front and I get y equals 2 over 3.